Hello, math magicians. Let's take a gander at number 8. A student's schedule consists of 6 class periods in math, English, history, language, science, and physical education, 2 of which meet before lunch. Wouldn't that be nice? A. How many ways can those first 2 classes be chosen? Well, this one's a fairly straightforward problem because we've got 2 classes to choose from out of 6. And since order is important, because math could come first, then English, or English, then math, and those are different. Order is different, so these are different sets each. All right, so because order is important, this is going to be a permutation. So it's simply 6p2 because we are choosing 2 from a group of 6. So punch that into your calculator and you'll get a reasonable answer, not too many. Okay, now that's part A. Now part B says, well, let's go ahead and see how many of these contain math as one of the 2 classes. Well, that one's not too crazy because if you have math first, you either have the English or the history, or the language, or the science, or the PE. So notice here there are 5 options. Well, the same is also true if you switch these positions. So you have 5 options here for math being first, and 5 options here for math being second. So add those together to get your answer. Now we're going to look at the next problem, number 14. A student has textbooks in algebra, geometry, biology, chemistry, function stat trig, and physics. These books are to be arranged on 2 shelves. How many different arrangements are possible if 3 books are on each shelf? And how many different arrangements are possible if the 3 math books are on one shelf and the 3 science books are on the other? And how many different arrangements are possible if each shelf has at least 1 book? So let's attack A first. All right, so if you have 2 shelves, so the first and order does matter. So you have 6 books to choose from, and we're going to put 3 on that. Now, once we have the 3 gone, we only have 3 left, and we are from there going to choose the 3. And here we go. So this would be how to set up A, and whatever you find out that answer to be, there's your answer. And so that'll give us quite a few, a couple hundred, many hundred. Okay, so let's keep going and look at B. So, B, how many different arrangements are possible if 3 math books are on one shelf and 3 science books on another? Well, here this is going to be a lot smaller because we only have 3 to choose from, and we're just arranging those in different orders. And then we're also going to do 3 science books and arrange those in different orders. And there you go. So those are your total options there for part B. Now part C is a little bit more complicated. How many different arrangements are possible if each shelf has at least 1 book? So if we put this as sort of like ordered pairs, the first shelf has 1, the second shelf has 5. The first shelf has 2, the second shelf has 4, etc. Right? So we think about these as numbered pairs. So if we logically deduce this one here, if we only choose 1, that means I have 6 options, but I'm only going to choose 1. And then the next one has 5 options remaining, and we're going to choose all of those. Now we're going to continue with this one. So we have 6, but we're only going to choose 2 of them. And the remainder is 3. The remainder is 4 books, and we're going to choose all of them. So there we go. And you can keep logically deducing these, and in the end, what we have is we're going to have 5 different options, and all we do is add them together. We have to add each of these together. So whatever you get here, add that to this one here, and then keep going because there are a total of 5 of them. And hope that helps. Fare thee well.